Hi, this is Julie Will presenting my final project for the application of learning theories. I chose to do my 5 lessons in my AP Statistics class. So the purpose of the project is to incorporate various activities based on different learning theories we talked about over the year to best help AP Statistics students discover and acquire new knowledge. The new knowledge that they acquire is going to increase their understanding of probability distributions, otherwise known as random variables, in order to help them prepare for the AP Statistics exam that they'll take at the end of the school year in May. So, of course, my audience is my AP Statistics students. Each of them have a strong background in math. They've taken and they've passed Algebra 1, Algebra 2, and Geometry. Most of them have taken and passed Trigonometry as well, and many of them are dual enrolled in either Calculus AB or Calculus BC at the same time as taking this class. So they are dedicated, they are focused, they are high achieving students, especially in the subject of mathematics. So for my project, I am focusing on discrete and continuous random variables. They're coming out of a probability unit. We're looking at probability distributions, now given the name discrete or continuous random variables. So they have a little bit of background knowledge of the probability aspect, but they have a lot to learn in this unit. So they have to be able to find expected value of a discrete random variable. They have to be able to calculate standard deviation of a discrete random variable. They have to be able to calculate probabilities within discrete or continuous random variables. They must transform a random variable from its original state by either multiplying or dividing it by a constant or adding or subtracting a constant to every value within that distribution. And finally, for this part of the year, they have to be able to calculate the mean and standard deviation of the sum, so when we combine two separate random variables. So, starting the unit off, lesson 1 with expected value. Expected value is also the same as the mean of a random variable. So, students are asked to define a discrete random variable. Later on in the chapter, I'll ask them to define a continuous random variable. And today, they're going to be asked to calculate the expected value. Now, they've never seen the term expected value before today, but being able to do so is fairly intuitive and simple enough that they should be able to figure it out on their own. So I give them a challenge question that's based off of a card game. So you can see throughout the year sometimes we play cards or we practice with decks of cards because a lot of the AP exam is based off of games of chance like card games. And with their prior knowledge of how games of chance works, how deck of cards are set up, they typically are able to answer the challenge question and they figure out on their own how to calculate the expected value of a discrete random variable completely on their own without my help. Now, it takes them a few minutes, whereas on the AP exam, I'm going to want them to be able to recall how to do it much more quickly. So I break them into groups and they have a couple group work questions, and then towards the end of class they'll do singular or independent practice just to reinforce the use of that formula that they were able to come up with earlier in the class. So if they are able to figure out how to calculate the expected value, figure out that formula on their own, I see some mastery of learning, and I'm definitely going to look at the completion and the mastery shown on the practice problems that they work on for the remainder of class to make sure that that new content is understood and retained. So I related this most closely to the cognitive information processing theory because even while they'll be able to figure out the formula after a while, I don't want it to take that long on the AP exam. So I want to transfer this knowledge that they kind of discovered on their own from their short-term memory to their long-term memory. So where they have to recall it much more quickly on the AP exam, they'll be able to do so. So lesson 2 is to be able to calculate the standard deviation of a random variable. So on purpose, I included what that formula looks like, and you can see it looks to be pretty complicated, because it is. So it's not as intuitive and it's not as easy as the formula for the expected value of a random variable. So I'm not expecting that any of the students are going to be able to use their prior knowledge to come up with that. So what they do is they will watch a screencast, kind of like what I'm making right now. I'll make a video on my computer that shows them the formula, shows them where it came from, shows them an example using it, and as long as they watch that and come back to class, that first day in class, I'll give them a problem when they first walk in to practice using this standard deviation formula. So this formula, because it's so complicated, is provided for them on the AP exam. What I'm more concerned about is obviously not them memorizing it because it's given to them on the AP exam, but do they know the pieces of notation that make up the formula? Do they understand why we are subtracting here, squaring there, multiplying, taking the sum? Do they know why we're ending with a square root? So why is all of this under the radical? So in this class, their biggest task is to write a letter to an absent classmate, explaining the notation, explaining why the formula looks the way it does. So they'll have plenty of time to ask questions as we're doing a practice problem at the beginning of class, and then they'll have to articulate a way to explain the mechanics of this formula to a student that, quote unquote, missed that day of class. If time remains at the end, they will just answer a few questions from an exit ticket that has them using the formula. But today, for me, the biggest piece is understanding the why behind that formula. So I most closely related this to Robert Gagne's theory of instruction. Robert Gagne felt that if the learners can paraphrase or explain the information that they have been presented, then they have shown that they acquired the correct information. They have shown that they've mastered the correct information. So to me, it's most important here to focus on what they were able to say in that letter to their absent classmate to show that they have learned and understand the use and the mechanics of this formula. All right, lesson 3. Move it up. Lesson 3 takes us away from discrete random variables and we move into continuous random variables. So they have seen and they have practiced continuous random variables before in chapter 2 of the AP statistics textbook that we focus on. So they have done problems just like this before. They just need to realize that instead of labeling them with 100 different possibilities, we're now labeling them probability distributions. So it's a little bit different in that sense, and I just need to remind them of what they already know. So today's lesson is a little bit about review. So I'm starting with a question on Socrative.com just to see how they fare with that, see what they can remember. It should spark some prior knowledge in order to help us at least remember that they're going to need to grab their calculators. They're going to need to remember how to type in different values that I provide them into the program we use in the calculator the correct way in order to calculate these probabilities. So while we can find a lot of these probabilities by hand on the AP exam, it's much faster and more effective to do it in the calculator. It's hard to remember what program to use, how to enter the numbers, how the program's supposed to run. There's a lot of calculator usage on the AP exam, and I want to practice that today. So I have a Kahoot quiz for them where they practice problems like this over and over and over again, and the winner, first place, gets a piece of candy, and the loser, as they're trying to catch up, is working to figure out what to do to get into a higher spot, racing their classmates. So I'm looking for those students who are not answering them correctly at first, how they're adjusting what they're doing in the calculator to get those answers right. And I'm looking for students who are getting those answers right as they go through to keep getting those answers right and keep figuring out the correct way to use that program and so on. So I most closely related this to behaviorism, as soon as they click the correct answer on their phone screen, so Kahoot is all online, it uses their cell phones, they see a big green check, they move up into first, second, or third place, and they know they're that much closer to getting the piece of candy. If they get the question incorrect, it's a big red X. They know they've done something wrong immediately, and they work to change that. So they work to not do it that way again, and they work to fix it, change it, so they get it correct. So that most closely reminded me of behaviorism, where behavior is reoccurring the more that we reward it. So the more they see that big green check, the more they're likely to repeat that behavior. So lesson 4, we go back to discrete random variables, and we introduce Pete's Jeep Tour problem. So Pete's Jeep Tour problem reminded me a little bit of Jasper Woodbury and his adventures, where Pete's a guy in the African safari and he has a Jeep tour. His Jeep tour represents a random variable. Depending on the day of the week or the particular day or the weather, he has different people showing up to ride his Jeep tours. So we're trying to help him out, figure out how much, based on how many people he might see per day, how much money he's going to make. Or what if he figures out that he has to pay a permit fee to cross a certain river? How is that going to affect his total takeaway, total income later on? So we're multiplying every aspect of Pete's random variable by a constant, and we are subtracting money away when he has to pay for his permits, and the students are doing this completely on their own. So they're reading through the problem, it prompts them with different scenarios, and they have to work together to figure it out. After they figured it out, I'll be around to check, and they'll show me, and I'll give them an exit ticket to apply it to a different problem. So it can be something totally different. It might be the amount of cars that are sold at a dealership on any given day. So I related this to constructivism. Constructivism focuses on existing experiences and having the students construct their learning to what makes sense to them. And so they can relate to businesses and people coming in and money and payments, and they have jobs. So they'll use that to help figure out what his total profit's going to be, what he's going to lose when he has to pay for those permits, and so on and so forth. And plus that collaboration aspect falls nicely into the constructivism paradigm. Finally, the last day of this small unit, we're going to introduce Pete's sister Erin. So Erin also has a Jeep tour company, and their father in this new scenario is interested in seeing how well those two would fare if they combined their business. So today is all about combining two random variables. So the students are going to break back into their groups, similar to the day before. They're going to have a list of scenarios, what's going to happen if Pete and Erin join forces versus perhaps the conversation at the dinner table with their father is more so, well, Pete, how much better do you do than Erin? So in that case, they're looking at the difference between two random variables. Or on any given day, how much better does Erin do than Pete? So looking there at either the sum or difference of two random variables. So because we were using similar methods from the day before, I related this to constructivism, but I also related this particular lesson to schema theory because we are taking the same scenario. So we're giving them this familiar context from the day before. They know about Pete. They know what happened when they transformed his random variable. And now we're looking at his sister Erin as well. So they're able to tie in this prior knowledge and tie in this common theme to help them, be more comfortable starting out and solving these types of problems together. So I'm going to be looking at whether or not they're able to do it as a group and then what they perform on a couple questions on an exit ticket. So the next day, they'll take a quiz on discrete and continuous random variables, hopefully able to use all the formulas correctly and able to apply them all correctly. But in reality for this class, the ultimate goal is always to better prepare them for the AP exam.